revise here. So in last class we discussed about first one, how to represent the first order differentiator and the second order differentiator using forward difference approximation, backward difference approximation, and central difference approximation. So here I am writing the central difference approximation because normally we have to use central difference approximation. So we have to write du by dx is equal to u I plus 1 minus u I minus 1 divided by 2h.
Sir,
So last class we discussed about the du by dx is equal to u I plus 1 minus u I minus 1 divided by 2h. So this one is a standard difference approximation of du by dx where h is the period of x data, the independent variable x, and I is used to indicate the points of x. I means current point of x, I plus 1 means next point of x, and I minus 1 means the previous point of x. Okay, so if it is with respect to y, then we have to write du by dy is equal to u j plus 1 minus u j minus 1 divided by 2k, where k is the period of y, j is the current point of y, j plus 1 is the next point of y, and j minus 1 is the previous point of y. Okay, and if both are present, if u is a function of both x and y, then in these two functions we have to include in this function we have to include j, and in this function we have to include I also. Okay, so that one is a different thing. Now second order differentiator, the second order differentiator term du d square u by dx square can be written as u I plus 1 minus 2 u I plus u I minus 1 divided by h square. So this is d square u by dx square. Similarly, d square u by dy square is equal to u j plus 1 minus 2 u j plus u j minus 1 divided by k square. So this is d square u by dy square. So this one is a finite difference approximation that we discussed in the last class. Then we started the discussion about the solution of partial differential equation. I told you we are discussing about only one type of partial differential equation, that is Laplace equation. Laplace equation. So Laplace equation means the type of partial differential equation that looks like d square u by dx square plus d square u by dy square equal to 0. In short, we can represent it as uxx. Double x means second derivative with respect to x plus uyy equal to 0. So this one is a Laplace equation. So in last class I told you we can replace this the partial differential equation using the finite difference approximation, and that is u I plus 1 comma j. Here we have to include j also, because in this particular function I is changing, j is constant. So u I plus 1 comma j minus 2 u I comma j plus u I minus 1 comma j divided by h square. So here you can see that j is not changing because the differentiation is with respect to x. Similarly, in the second function x is not changing, the differentiation is with respect to y. So we can write it as u I comma j plus 1 minus 2 u I comma j plus u I comma j minus 1 divided by k square equal to 0. So this one is the finite difference approximation of Laplace equation. Okay. Then we made an assumption to simplify this equation. The assumption is the period of both x and y are equal, means h is equal to k. If h is equal to k, we can replace this term with h square. So now what is advantage? The denominator is h square and right hand side is 0. So we can remove h square. So with the assumption h equal to k, finally we derive the standard 5-point formula, that is equal to u I comma j is equal to u I plus 1 comma j plus u I minus 1 comma j plus u I comma j plus 1 plus u I comma j minus 1 divided by 4. So this equation is known as standard 5-point equation or 5-point formula. So what's the thing? So if you have xy coordinate, this is xy coordinate, the index used to represent x is I. I is used to represent x. So this is x, say xi minus 1, this is xi, this is xi plus 1, like that it will go. Similarly, the index used to represent y is j, means we can write this is yj, this is yj plus 1, so, okay, this is yj minus 1, this is yj, and this is yj plus 1. Okay, with one assumption, if you are applying this formula, the period, this period and this period are equal, the period of x and period of y are equal. So here in this equation we are finding ui comma j. So this is xi and this is yi. So this point is uh, uh, ui comma j, and we are finding this value using ui plus 1 comma j, that is this particular point, that is next point with respect to, means right point. Then ui minus 1 comma j, that is this point, that is left of ui comma j. Then ui comma j plus 1, that is top point, and ui comma j minus 1, bottom point. So by using left, right, top, bottom points, we are finding the center point, or by taking the average of left, right, top and bottom points, we are finding the current value, means center value. So this is known as the standard 5-point formula. Okay, so please note, this is ui minus 1 comma j, this is ui plus 1 comma j, this is I comma j minus 1, this is I comma j plus 1. So by using these 4 points, we are finding ui comma j. In last class I told you we can do some slight modification on this one. Instead of taking left, right, top, bottom points, we can take diagonal points like this point, this point, this point and this point. So instead of taking this into points, that is neighbor point, we are taking circle points, that is diagonal points, and we can take the average of these diagonal points. Okay, so it is known as diagonal 5-point formula. Diagonal 5-point formula. So the diagonal 5-point formula is ui comma j is equal to ui minus 1 comma j minus 1 plus ui plus 1 comma j minus 1 plus ui minus 1 comma j plus 1 plus ui plus 1 comma j plus 1 divided by 4. So this is diagonal 5-point formula. So please note here, the more precise one is standard 5-point equation than diagonal equation. Standard 5-point equation or standard 5-point formula is the precise one. So in last class we discussed about all these questions. Okay, so now we are going to solve a Laplace equation using this finite difference approximation method. Okay, so the question will be like question, solve Laplace equation. Laplace equation. It is also known as ellipse equation. So solve Laplace equation uxx plus uyy equal to 0 where following mesh represents the Laplace equation. Following mesh represents the Laplace equation. Okay, so you can see a diagram also normally. Otherwise, they will write the equation of that mesh. നമുക്ക് രണ്ട് problem ചെയ്തു നോക്കാം. First one is we have a mesh. This is x, this is y. So the mesh is like this one. This one is the mesh. Okay, so this is x0. So this x0 is 0 and corresponding u value, this u value is 0. This is 1, this is 2, this is 3. Okay, similarly this value is this is also 0, y value is 0, this is 1, this is 2, this is 3. Now you can see that the period of x equal to 1, period of y equal to 1, so both are equal, so we can apply standard 5-point formula. Now the boundary values are given. The boundary values are given. This is 0, this is 0, this value is 0, this value is 0, this value is 1, this value is 4, this value is 9, this value is 0.5, this value is 2, this value is 4.5. Okay, now this value is 7.5, this value is 6. So these are the boundary values. So please note down this equation, sorry, please note down this question and this mesh. Okay, we measure ശ്രദ്ധിക്കുക. This one is a square mesh. Here you can see that x is varying from 0 to 3, 0, 1, 2, 3 are the values of x. Similarly, the y values are 0, 1, 2, 3. Now with this 3 into 3 data, we have a mesh, a square mesh. The values of this mesh, boundary values of this mesh are corresponding to 0, 0, we have 0. Corresponding to 0, 1, we have 0. Corresponding to 0, 2, we have 0. Corresponding to 0, 3, we have 0. Now the next point, corresponding to 1, 0, we have 1. Then corresponding to 2, 0, we have 4. And corresponding to 3, 0, we have 9. Now take this boundary, rightmost boundary. The bottom point is corresponding to 3, 0, value is 9. Corresponding to 3, 1, value is 7.5. Corresponding to 3, 2, value is 6. And top right point is corresponding to 3, 3, value is 4.5. Now the top boundary, the upper boundary, corresponding to 0, 3, value is 0. Corresponding to 1, 3, value is 0.5. Corresponding to 2, 3, value is 2. And corresponding to 3, 3, value is 4.5. So this one is the boundary values of this mesh. X is in between 0 and 3, including 0 and 3, 0, 1, 2, 3. Okay. Then y is the integers from 0, 3, including 0 and 3. It's a closed bracket. So this one is a boundary. Okay. Now the boundary values are given. You can see that the bottom boundary is u is equal to, the bottom boundary is u is equal to x square if y equal to 0. So this one is a equation that is representing the bottom boundary. U equal to x square if y equal to 0. What about this top boundary? The top boundary is u is equal to x square by 2 if y equal to 3. This is y equal to 3. If y equal to 3, then u equal to x square by 2 if y equal to 3. Now what about this boundary? This boundary is u equal to 0 if x equal to, so here this one is a vertical line, so in vertical line x equal to 0. So if x equal to 0, what will be the value of y? U equal to 0. Now what about the right vertical line, this line? This line is u is equal to, you can see that it is varying from 4 to 9. So if x equal to 0, if x equal to 0, it is 9. So definitely a plus 9 is available here, plus 9. Okay. Now you can see that after each point, that 9 is decreased to 7.5, then decreased to 6, decreased to 4.5, etc. So here the coefficient, it is decreasing, so negative, and the decrement with respect to 1 unit, 0 to 1 is 1 unit, the decrement is minus 1.5. So this is minus 1.5 y plus 9 if x equal to 3. So this one is the right boundary. U equal to minus 1.5 plus, sorry, u equal to minus 1.5 y plus 9 if x equal to 3. So what I am trying to say is, I had given a pictorial representation of the function, pictorial representation. In some situation, instead of pictorial representation, they will not give this picture. Instead of giving this picture, they will give this boundary equation, like solve Laplace equation uxx plus uyy equal to 0 for the region x from 0 to 3 and y from 0 to 3 with the boundary equations u equal to x square by 2 if y equal to 3, u equal to minus 1.5 y plus 9 if x equal to 3, u equal to x square if y equal to 0, and u equal to 0 if x equal to 0. Okay, so it depends. Normally they will give the pictorial representation. In some situation, instead of this picture, they will give the equation. So you have to do one thing. Please note down the question, this picture, and also that boundary equation. Okay, note down all these things. Then we can start the derivation. Sorry, solution. So how many points we have to find? Anyway, we can't find a point lying outside this boundary. That is not possible by using standard 5-point formula. Okay, because standard 5-point formula is a formula which is used to find the center data by using its boundary, its naive. Okay, so always we can find the value of points that is lying inside this mesh. Okay, so how many points are there? So this x equal to 0 and y equal to 0. This point is already available. This is 0. Now x equal to 1, y equal to 0. This one is a boundary that is already available. X equal to 2, y equal to 0. That is this point. This point is also available. Now x equal to 3, y equal to 0. That is 9. That is already available. So that bottom line is already known to us. Now take the next line. X equal to 0, y equal to 1. This point is also available. That is 1. Now take the next one. X equal to 1, y equal to 1. So this point is not known to us. This point. So we have to find it. So what is the label we can use? This label. What label we can use? Its x index is 1, y index is 1. So we can use it as u11, right? u11. Am I correct? Any doubt? X index is 1, y index is 1. So we can label that point as u11. Okay. So can you write u11 using standard 5-point formula? What is u11 by using standard 5-point formula? Standard 5-point formula is the left data plus right data plus bottom data plus upper data. So please give me what is u11. Left data is 0, right? This is 0. left data is 0. So 0 plus. Now the bottom data of this is the point we are finding. So its bottom data is 1. So 1 is bottom data. So plus 1. Now what about the right data? This is right data, this particular one. This one is also unknown to us. So we have to represent it. What we can use? We can use its x index is 2, y index is 1. So we can write u21. u21. So that is the right point of u11. u21 is the right point of u11. So we can write it as u21 plus what is the top point of u11? That is this particular one. This point is what? What is the x index? Please tell me. Please tell me what is this point? How can we represent this point?
U12.
Yes, u12 because x index is 1, y index is 2. So u12 divided by 4. Divided by 4. Okay. So by using the standard 5-point formula, u11 is equal to left point 0 plus bottom point 1 plus right point u21 plus top point u12 divided by 4. So this is u11. Okay. So now my question is, now we have to find the second point. What is the second point? u21. Always first go to left to right. Then once that line is over, go to the upper line. Like that way we can address each point. What is the next point? u21. So u21 is equal to what? Similarly find what is u21. Left point plus bottom point plus right point plus upper point. So please find it. Please tell me what is u21.
U11
Uh,
plus 4 plus
uh,
7.5 plus
uh.
U22.
Yes, exactly. Because we need a representation for upper term. This upper term is u22 because the x index is 2, y index is 2. So the upper point of this one is u22. So we can write left point is
by 4.
so left point is 0, bottom point is 4 plus right point is 7.5. Sorry, one minute. Okay, so here we have u11 plus then 4 plus 7.5. 7.5 is the right point plus top point is u22 divided by 4. So this is u21 for u11 plus 4 plus 7.5 plus u22 divided by 4. Now what about this point u12? What about u12? What about u12?
0
Left
plus
point is 0 plus bottom point is this one u11. Bottom point is u11, right? Bottom point is u11. What about right point?
U22.
u22, yes. Then top point
0.5.
0.5, yes. So this is left point is 0, then lower point is u11 plus right point is u22 plus top point is 0.5 divided by 4. Okay, so this is u12. Now one more point we require, u22. So what is u22?
U12 plus U22 plus 6 plus 2 by 4.
U22 is equal to left point is U12 plus bottom. So we are finding this point. So its bottom point is U21. So U21 plus the right point of this one is 6. So 6 plus its top point is 2. So plus 2 divided by 4. So now we have all 4 points because inside this mesh boundary we have to find 4 points. So we can write this one neatly. So U11 is equal to 0 plus 1 is 1. So 1 plus U21 plus U12 divided by 4. So this is U11. Similarly, we can write U21 is equal to, so here we have constant 4 plus 7.5, so that is 11.5 plus remaining terms are U11 plus then we have U22, we have U22 divided by 4, so this is second term. Okay, the third term is U12 is equal to, this is U12, so here 0 plus 0.5, that is 0.5 plus U11 plus U22 divided by 4, and last equation is U22, so this is U22, here the constant is 6 plus 2, 8, so 8 plus U12 plus U21 divided by 4. So we have 4 equations, U11, U21, U12, U22. We have 4 equations. So please note, we have 4 equations. We have 4 unknown variables. 4 equations, 4 unknown variables. So this is a linear system. This one is the linear system. ഞാനത് അങ്ങനെ പറയാൻ കാരണം നിങ്ങൾ S4 ന്യൂമറിക്കൽ മാത്തമാറ്റിക്സിലെ ഒരു ടോപ്പിക് എന്ന് പറയുന്നത് ന്യൂമറിക്കൽ മെത്തേഡാണ്. അതിൽ നിങ്ങൾ പഠിക്കുന്നത് സൊല്യൂഷൻ ഓഫ് ലീനിയർ സിസ്റ്റംസ് ആണ്, അതായത് മെട്രിക്സ് എങ്ങനെ സോൾവ് ചെയ്യാം എന്നുള്ളതാണ് പഠിക്കുന്നത്. So a number of methods you have studied. That is, one is direct method and second one is direct method means elimination method, and second one is a iterative method. So Jacobi method is, so these are the equations. So assume that all these, the initial values of all these variables are 0. So this is iterative number, this is iterative number, this is U11, this is U21, this is U12, and last one is U22. So these are the thing. So before iteration, so 0th iteration, the initial values are 0. So this is n, means already available values. This is n, this is n, this one is n, this is n. Now left side is the new value. So n plus 1, n plus 1, n plus 1, n plus 1. So if you are substituting 0, 0 here, ഈ equation U21 equal to 0, U12 equal to 0. കാരണം ഇതാണ് current values, 0, U21 equal to 0, then U12 equal to 0. So ഈ രണ്ട് values first equation substitute ചെയ്യുമ്പോൾ, what is the new value of U11? Please tell me. If I am substituting U21 equal to 0 and U12 equal to 0, what is the new value of U11?
1 by 4.
1 by 4. That is 0.25. നമ്മൾ ഒരിക്കലും ന്യൂമറിക്കൽ മെത്തേഡിൽ ഫ്രാക്ഷൻ യൂസ് ചെയ്യാൻ പാടില്ല, മീൻസ് 1/2 ratio use ചെയ്യാൻ പാടില്ല. So 0.25. So u11 is equal to 0.25. Okay. So number first iteration now u11 is over. Now what about u21? What is the value of u21? So for u21, u11 and u22 are there. So this is the current value. അത് വളരെ കെയർഫുൾ ആണ്. ജക്കോബി മെത്തേഡ് ആണ് യൂസ് ചെയ്യുന്നത്. If you are using Jacobi method, and if you are finding the first row data, we have to use the 0th row data. Please note, if you are finding first row, we have to use the 0th row data if you are using Jacobi method. So in order to find u21, u11 equal to 0, this is 0, and u22 equal to 0. This one is also 0. So what about u21? What is the value of u21? 2.875. Very good. So u21 equal to 2.875. Okay. So this one is over. Now u12. For u12, we need u11 and u22. So this is u11, that is equal to, I told you we have to use 0th row data. So u11 equal to 0, then u22 equal to 0.
Point 125.
Point 125, right? This is 0.125. Okay. So this one is also okay. Now what about u22? So for u22, 8 plus u12. So this is u12, this data, that is 0. Then u21. So this is u21, that one is also 0. So 8 plus 0 divided by 4. So that is clear output 2, right? So now the first iteration is over. So now we have to start from u11. So we are going to start the second iteration. So now what is u11? So for second iteration, we have to use first row data. So here u11 equal to 1 plus u21. So what is u21 now? Which data we have to use?
0.25. 2.87.
This data we have to use because we are finding second row data. So we have to use first row data. So 2.875, that is u21. Similarly, plus u12. What is u12? 0.125. That one is the first row data. Now forget about the 0th row data. That one is over. Now we have to use first row data to find second row data. Okay. So use 2.875 as u21 and 0.125 as u12 to find u11. So what is the answer?
One.
Yes, very good. So the value of u11 is 1. Now find u21. u21 equal to what? So for u21, 11.5 plus u11. So this is u11 0.25 plus u22. u22 is 2. So what is the answer? 11.5 plus 0.25 plus 2 divided by 4 is what?
3.4375.
3.4375, right? 3.4375. So that is u21. Now find u12. What is u12? What is u12? 0.5 plus u11. u11 is 0.25, this data, plus u22. u22 is 2. So what is the answer? Point
0.6875.
0.6875. Now what is the last data? U22. Eight plus U12 is 0.125 here, and U21 is 2.875. So this is
2.75.
2.75. Okay. So second row is over. So do one thing, all of you, please complete this one. This one is the second iteration. U11 equal to 1, U21 equal to 3.4375, U12 equal to 0.6875, then U22 equal to 2.75. Then we have to calculate, we have to start the third iteration. First one is U11. So U11 is equal to 1 plus this 3.4375. This is U21 plus U12, that is 0.6875 divided by 4. So we have 1.2813. Okay. Then we have to calculate U21, that is equal to 11.5 plus this 1 plus this 2.75, that is U22 divided by 4. So this is equal to 3.8125. Then we have to calculate U12. So U12 is equal to 0.5 plus U11, that is 1 plus U22, that is 2.75 divided by 4. So the answer is 1.0625. Then we have to calculate U22. U22 is equal to 8 plus U12, that is 0.6875 plus U21, that is 3.4375 divided by 4. So that answer is 3.0313. So the third iteration is over. So like that way we have to continue. So after the fourth iteration, these are the values. That is U11 equal to 1.4688, U21 equal to 3.9532, U12 equal to 1.2032, U22 equal to 3.2188. Now this is fifth iteration. U11 equal to 1.5391, U21 equal to 4.0469, U12 equal to 1.2969, and U22 equal to 3.2891. So if you are continuing up to 10th iteration, these are the values. Means U11 is equal to 1.6226 after 10th iteration, U21 equal to 4.1224, U12 equal to 1.3724, U22 equal to 3.3726. So exam point of view, if you have only 4 variables, you have to do up to 10 iteration, and if you have 9 variables, you have to do up to 5th iteration. Okay, so please note that exam point of view. But in real life, what is the termination condition? The termination condition is if the current iteration value and the previous iteration value are same, then we have to stop. So here you can see that 10th iteration values and 9th iteration values are not same. So in real life, we have to continue it. So this is 11th iteration, again it is not same, so we have to continue. So this is 12th iteration, again it is not same, then we have to continue. So this is 13th iteration, that is not equal to the 12th iteration value, so we have to continue. Now this is 14th iteration, so you can see that 14th iteration is not equal to 13th iteration, but it is very close to each other but not equal, so we have to continue. Now this is 15th iteration, so the 15th iteration is also not equal to 14th iteration, so we have to continue. Now you can see that 16th iteration is exactly equal to the values of 15th iteration. So after 16th iteration we can stop. Okay, in real life. So when the current iteration and the previous iteration are exactly same, or the difference is negligible, we can stop it. Okay. So this one is the solution of Laplace equation using the Jacobi method. Okay. Any doubt?
No, sir.
Okay. So the same thing we can solve by using Gauss-Seidel method. So in Gauss-Seidel method, the thing is, this is first variable u11. So for first variable, always remember the left variables are assigned as n plus 1, means new data. What about right data, right hand side? For first equation, all away these u11, u21, u12 are for the current iteration, the latest data of u21 and u12 are not available. So we have to label n and n here. For all right hand side variables, assign n. Now what about u21? For u21, you can see that this u11 is available. The new data of u11 is available. So we can take this data. We can utilize the latest u11 data. This data we can use. Okay, this data we can use. This data we can use. Okay, so what I am trying to say is, for u21 we can use this u11. So we can write it as n plus 1. This u11 is n plus 1 because latest data is available. But u22 is not latest, last iteration data. Last iteration data we have to use. So u22 is n. Now what about u12? For u12, this u11 is available here. But what about u22? Again u22 is not available. So u11 is n plus 1 and u22 is n. Wherever the latest data is available, label it as n plus 1. If the latest data is not available, label it as n. Okay. Now what about this u22? For u22, this u12 is available. Also this u21 is available. So you can write it as n plus 1 and n plus 1. Okay. So please note, in Gauss-Seidel method, we have to use the latest data. We have to use latest data. Whether it is the current iteration or previous iteration, that is not important. What is the latest data available, that we have to use. Is it clear, all of you? So by using Gauss-Seidel method, again solve this problem and find the answer. Again we have a serial number iteration, then u11, then u21. In this order, please write the column u21, then u12, then u22. So for serial number 0, all data are 0. Now first iteration, for u11, you can see that the latest data are 0, 0, 0, 0. So in order to find u11, you have to use 1 plus u21 is 0, this data, then plus u12, this data we have to use. So 1 plus 0 plus 0 divided by 4, it is 0.25. This is 0.25. For u11. For u11, we use u21, this one is the latest data, and u12, this one is the latest data. So 1 plus 0 divided by 4. Now if you are using u21, if you are finding u21, 11.5 plus u11, you can see that now this data is available. 0.25 is available. So there is no need to use this 0. Always use latest data. So u11 equal to 0.25. But what about u22? For u22, we have to use this data. So please note, we have to use 11.5 plus 0.25 plus 0 divided by 4. Okay, always use latest data. So 11.5 plus 0.25 plus 0 is 11.75 So this is 2.875. This data is 2.875. Now take U12. For U12, we have to use 0.5 plus U11. So this is the latest data, plus U22. So this one is the latest data. So we have to use 0.5 plus 0.25 plus 0 divided by 4. Okay.
സർ
പറഞ്ഞോളൂ.
U21 എനിക്ക് 2.93 അങ്ങനെ കിട്ടിയത് 9375.
ഞാൻ ജസ്റ്റ് മനക്കണക്കാണ്, ചിലപ്പോൾ നിങ്ങൾ ചെയ്തായിരിക്കും കറക്റ്റ്. അതായത് U21 അല്ലേ പറഞ്ഞത്. അപ്പോൾ ഈ കേസിൽ U21 ഈക്വൽ ടു 11.5 plus now U11 is 0.25 plus U22 is 0 divided by 4, so that is equal to 11.75 divided by 4, so 11 by 2 37, correct, 9, 2.9, then 15, 35, 2.935, right?
9375.
9375. Okay. 9375. Okay. So 2.9375, right? Okay. ഞാൻ കാൽക്കുലേറ്റർ യൂസ് ചെയ്തിട്ടില്ല ചെയ്യുന്നത്, അപ്പോൾ മിസ്റ്റേക്സ് വരാം. താങ്ക് യു, കറക്റ്റ് ചെയ്ത് തന്നതിന്. 2.9375. ഓക്കെ. So U21 is 2.935. Now find U12. U12 is equal to 0.5 plus U11. U11 we have to use 0.25. So 0.25 plus U22 is 0. So 0 divided by 4. So this is equal to 0.75 divided by 4. So 0.1875, right? 0.1875, is it correct?
Yes, sir.
Okay. So
It's correct.
0.1875. Okay. Now similarly U22 is equal to 8 plus, now U12, this data we have to use, so 8 plus 0.1875 plus U21 we have to use this data, that is 2.9375 divided by 4. So the three number 8 plus 0.1875 plus
2.7813.
2.7813. Okay. So this is iteration number 1. So all of you please complete this one. So the advantage of Gauss-Seidel method is the convergence rate is more compared to the Jacobi method. നമുക്ക് ജക്കോബി മെത്തേഡിൽ 16 ഇറ്ററേഷൻ ആണ് പിടിച്ചത്. Gauss-Seidel മെത്തേഡിൽ അതിനൊക്കെ കുറവ് ഇറ്ററേഷനേ വരുള്ളൂ. So anyway, as we have 4 variables, do 10 iteration, maximum 10 iteration. So find the answer. So we already completed the first iteration. Now if it is second iteration, then for U11 we have to use U21, that is 2.9375, and U12 0.1875. So it is 1 plus 2.9375 plus 0.1875 divided by 4. So the answer will be 1.0313. Similarly for U21 we have to use the latest data of U11, that is 1.0313, and latest data U22, that is 2.7813. So we have 11.5 plus 1.0313 plus 2.7813. So the answer is 3.8282. Now for U12 we have to use the latest data of U11, that is 1.0313, and the latest data of U22, that is 2.7813. So we have 0.5 plus 1.0313 plus 2.7813 divided by 4. So the answer is 1.0782. Now similarly we have to use for U22 we have to use uh, latest data of U12 that is 1.0782 and latest data of U21 that is 3.8282. So we have 8 plus 3.8282 plus 1.0782 divided by 4. So the answer is 3.2266. So this one is the second iteration. And after the third iteration, we have U11 equal to 1.4766, U21 equal to 4.0408, U12 equal to 1.3008, and U22 equal to 3.3379. Now, after the fourth iteration, we have uh, U11 equal to 1.5879, U21 equal to 4.1065, U12 equal to 1.3565, U22 equal to 3.3658. So this one is not converged, so we have to continue it. So this one is the fifth iteration. So you can see that the values are again modified. This one is the sixth iteration. Again values are modified. This one is the seventh iteration. So the values are again modified, but you can see that slowly it is converging. So soon it will converge. So after the eighth iteration, these are the values. Okay, again it is not converged. Now after the ninth iteration, you can see that U11 value is modified. All other values remains constant. So again we have to continue. Now after the 10th iteration, we can see that all values are constant. So all values are converged. So we can stop here. So it took exactly 10 iterations to get the final answer. So you can see that Gauss-Seidel method is more faster than the Jacobi method, or the speed of convergence is more for Gauss-Seidel method than Jacobi method. Okay. So this one is a general advantage. So in order to satisfy, in order to get the large speed of convergence, there are certain conditions, but that condition there is no need to discuss about those conditions because we are not discussing about what is Jacobi method and what is Gauss-Seidel method. Here we are just applying these two methods. So there is no need to discuss about the advantages and disadvantages of Gauss-Seidel method and Jacobi method. Okay, I just I'm just saying that Gauss-Seidel method is the superior one than Jacobi method uh, based on this problem. Jacobi method is slower, Gauss-Seidel method is the faster one. Okay.